2A. To get a web page with some text and three images, a browser needs to send one request message and receive four response messages. Now this will be forced. The reason is this: the browser needs to send four request messages for the four objects, the text and three images. Two pages, example www.uky.edu/research.html and www.uky.edu/index.html can be sent over the same persistent connection, and this will be true. When the browser contacts the same website, it can actually send as many web objects through the same persistent connections. Part 3. With non-persistent connection, it is possible for a single TCP segment to carry two distinct HTTP request messages, and this will be forced. One single TCP segment can only carry one and most one HTTP request messages. At the terminations, which is the two carriage return, the HTTP would not respond anything further after the two carriage return, so you cannot embed two request message within the same TCP segment. Part 4. HTTP response messages never have an empty message body. This is false again. The reason is this: that sometimes the response message can be empty. For example, in a conditional get message, the request message asks for a response only if the response is newer than the cache copy. So if the cache copy is current, then the response message will be empty. One reason for having a proxy server is to provide caching. This is absolutely true. The proxy server can serve many purposes, for example as a translations or as a mobile presenters, but one of the main reasons to have a proxy server is that it provides web cache. Part B. Agent 586 of the FBI walks into Ovid's cafe, which has wireless internet and runs its own local DNS server. The agent wants to figure out whether anyone in the cafe has recently accessed www.bigspy.uk before Agent 586 arrived. How can the agent do this using standard computer networking tools and without breaking into any computers or server? Now this is a tricky question, of course. If anybody has actually accessed the particular websites, the local DNS server will have a cache copy. So the local server must have a cache copy of the IP address of www.bigspy.uk. So we simply need to do an NSLOOKUP. NSLOOKUP will first look at the local DNS server. So the local lookup will return the IP address immediately without further query. So it will return the IP address a lot faster. And sometimes it will even indicate that this is a local cache copy. Part C. Consider the following circular distributed hash table, which is this one. Okay. Describe the steps a new peer 6. So you have a new peer, peer 6. Needs to take, in order to join this new DHT, assume peer 6 initially only knows the IP address of peer 15, which is this guy. Okay, so the step 1 is that, well, peer 6 only knows peer 15, right? So so peer 15 have to find out that where is the proper locations for peer 6 to join. So the first one is that peer 15 will ask for the well, actually for us, for the predecessor of peer 6. So it will first send a message to the next peer, which is peer 1, and then peer 1 will forward to peer 3, peer 3 will forward to peer 4, and then peer 4 will forward to peer 5. Now peer 5 immediately knows that its own successor is peer 8. Okay, so it will realize that, oh, okay, 6 is actually should fit in here. So the second step is that peer 5 will forward these two messages to peer 6. Now, all this asking around message will contain the IP address of peer 6. Okay, so this one has the IP address of 6. This one also has IP address of 6. So now, this one also has the IP address of 6. This one also has IP address of 6. So now 5 know the IP address of 6. So peer 5 will now tell peer 6 that, oh, okay, I know that this is my IP address, and also that the peer 6's successor should be peer 8. So you also send the IP address of peer 8. So now peer 6 know. So peer 6 now should make peer 8 its successor. So start peer 6, peer 8 is successor. So this is step 3. Okay, and then peer 6 will also ask peer 5 to know, okay, I am now your successor. So it will have a response message saying that peer 5 should be now my successors. Okay, so peer 6 will ask 8 to be his successors, and 5 to be its predecessor. Okay, so that's the step that needs to happen before peer 6 become part of the DHT. Okay. Part D. Describe the steps the server needs to take in a typical network program with sockets. The first step has been filled in for you. Now, some of you make a mistake by writing the TCP handshake. This should not be an error that is made, because I already mentioned the first step for you, which is create a socket. So the step for a server to take is the second step would be bind the sockets to the port, to the advertised port. As a server, it has to advertise the ports, otherwise other clients will not know that the service is offered by the server. The third step is that it will start listening to the socket for incoming clients, and then when a client starts to call, the server will examine whether they have enough resource, and then it will connect to the sockets. It will then create a sockets, and then it will start sending and receiving data. And when it is done, it will close the socket. Okay, there are some variation in terms of the steps. So we have created this with some flexibilities, but it should include essentially every one of the steps that I have mentioned in here.